Welcome back. In this video, I'm going to show you two examples of how we go about solving linear equations where the equations are composed of algebraic fractions in either side of the equation. So example 8 here, we have 2x plus 3 all over 4, and that's equal to x minus 2 all over 3. Now the way in which we're going to go about solving this equation is we're going to have to rely on our understanding of algebraic fractions and simplification. So the exact process I'm going to do is, firstly, I'm going to move both of these terms to the same side of the equation. Then I'm going to simplify both equations such that I can rewrite them as a singular equation. So I need to have a common denominator. Then I'm going to cancel out the denominator and finally solve it like I would any other equation up until now. So doing that, I'm going to move the left-hand side expression to the right-hand side. So that's going to look like minus 2x plus 3 all over 4. Then we'll go minus 2x plus 3 all over 4. That will give us 0 on the left-hand side and x minus 2 all over 3 minus 2x plus 3 all over 4 here. Now our next step is, notice we have two fractions, but they're of differing denominators. One has a denominator of 3, the other has a denominator of 4. What we want to do is we want to have a common denominator. Now 3 and 4, there's nothing in common between the two of those. So what we need to do is we need to go 3 by 4, and that will give us 12. So our target is going to be a common denominator of 12. Now doing that, I'm going to multiply the first fraction here by 4 in the numerator and 4 in the denominator, and then the second by 3 in the numerator and 3 in the denominator. So that's going to look like 4 upstairs and downstairs, and we'll put the implied brackets on it as well. Then times 3 upstairs and downstairs for this second fraction. Evaluating this, we're going to get 4x minus 2 all over 12, and then 2x plus 3 all over. Now we have a common denominator. We can rewrite this as a singular fraction of 4x minus 2 minus 2x plus 3. And all of this is now over 12. Now, this is our right-hand side. Our left-hand side is still equal to 0. Now, I'm going to go for a simplification process here, because I really don't like fractions. If I can get away with not working with them, I will. So what I'm going to do is, on either side of the equation, I'm going to multiply it by the denominator. What this will do is 0 by 12 will still result in 0, but over on the right hand side here, we're going to get 4 times x minus 2, 2x plus 3. So we completely eliminate having fractions altogether. So 0. Now, because it's 0 on the left here, we deal with what we've got on the right here. So I'm going to expand the brackets. So expand the brackets here and here. We'll get 4x minus, or plus I should say, 4 times negative 2. Then we're going to get plus, and then we'll have a minus 3 times 2x plus minus 3 multiplied by 3. Simplifying, or I should say evaluating, 4x plus minus 8 plus negative 6x plus minus 9. Getting rid of these pluses that we don't need anymore. 4x minus 8 minus 6x minus 9. Now we're going to collect like terms. Minus 4x minus 6x, that's minus 2x. Minus 8 minus 9, that's negative 17. Moving the constant terms to the right and the variable terms to the left, we're going to get, so variable constant, the variable needs to go to the left, so it's minus 2x plus 2x. We still have 0 on the left hand side. Need more space, so I'll move this down. Therefore we have 2x is equal to minus 17. Now I don't want the coefficient of 2 in front of this x, so I'm going to divide everything by 2. Then we get x is equal to minus 17 divided by 2, and that can be simplified down to negative 8.5. So depending on which one you want, you can go that answer or you can go that answer, personal preference. So in hindsight, what we did was, firstly, we moved everything to one side of the equation. Then we went for a common denominator using our simplification rules that we learned in the last topic. After that, we had a singular fraction. So singular fraction here. We multiply both the left-hand side and the right-hand side of the equation by the common denominator, which was 12. That removed all fractions. Then we opened our brackets, collected like terms, and then simply solved for x. So probably 1, 2, 3, 4, 5. 5 steps involved in this one. Now, let's go for a similar problem. We'll go to a new page because I'm not sure if we'll have enough space left on that one. These problems can be quite long. We're going to go 2 minus x all over 4 is equal to 3x minus 2 all over 5. We're going to follow the exact same process as seen before. So first things first, we want to move everything to one side of the equation. I've got more space on the right, so I'll move the left to the right. So we're going to take 2 minus x over 4 from both sides of the equation. This will yield nothing on the left. Next step is we want to have a common denominator. Now notice 5 and 4, 5 is a prime, 4 is a composite. There's nothing in common between the two. So what we're going to do is we're going to go 5 times 4, that's 20. So we're going to go for a common denominator of 20. That will look like brackets, multiply 4 and 4, multiply 5 and 5. Simplifying, 4, 3x minus 2, take 5 times 2 minus x. And that's now all over 5 times 4, which is, now we have 20 on the left, 20 on the right. We don't like fractions, so we multiply both sides of the equation by the denominator of the fraction, and that yields 0 on the left still. 4 times 3x minus 2 on the right, minus 5 times 2 minus 2x. Like so. Next step, expand the brackets. So these guys here, they've got to open up. This will give us 4, 3x plus 4 times minus 2 plus minus 5 times 2 plus minus 5 times minus x. Simplifying using algebra, 4 times 3x is 12x, plus 4 times negative 2 is minus 8, plus minus 5 times 2 is minus 10, plus minus 5 times minus x, double negative, that's going to be positive 5x. Rewriting without the superfluous pluses, minus 8, minus 10, plus 5x. Now we're going to collect like terms. 12x plus 5x is 17x. Minus 8 minus 10 is negative 18. Next step, I should say left hand side still equal to 0. Next step, we want to move all of our variable terms to the left, keep all of our constant terms on the right hand side. To do that, we have to take 17x from either side of the equation. This will yield negative 17x on the left hand side negative 18 remains on the right hand side. Now we've got this negative 17 over on the left here, so I divide both sides by negative 17. This in turn yields x is equal to negative 18 divided by negative 17. Double negatives here, they're going to cancel out. So we get 18 over 17, and we might be tempted to evaluate this, but we definitely won't do that because 17 is in fact a prime number. So 18 over 17 is an irrational number. So therefore we leave it as x equals 18 over 17. So once again, looking back, we started off with this linear equation where we had fractional algebra on either side, algebraic fractions on either side. We first move everything to one side of the equation. We then simplify the two fractions such that we have a singular fraction. So we multiply by 4 and 5s to get a common denominator. Once you have a singular fraction, multiply through by the denominator of the fraction to cancel the fraction out. Therefore, we're simply left with a linear equation on the right hand side and nothing still on the left. Then it's simply a matter of open the brackets up, collect like terms, move the variable terms to the left, constant terms stay on the right, get rid of the coefficient, solve for x. Nothing to it.